Alright guys, this is section 1.4, properties of real numbers. This section, the notes are going to be a little bit longer. There will be a lot of writing. I'm hoping that some of these properties are review. You've heard about them before, maybe you don't remember them, but we are going to go over them again today. So first thing I have for you is a definition. Equivalent expressions. This is going to be two or more expressions that have the same value for all value of the variables. Okay. So looking at an example of that, 9/3 plus a is equal to 3 plus a. And hopefully we can see right away that if we take 9 divided by 3, that's going to equal 3. So we can see they're going to be the same on both sides. But notice even when we plug in a value for a, let's say a equals 2. So we have 9/3 plus 2 equals 3 plus 2. On the left-hand side, 9/3 plus 2 simplifies down to 5, and on the right-hand side, that simplifies down to 5 as well. So that is one example of equivalent expressions. Okay. And that's the only vocabulary that we have for this section. But starting with our properties of real numbers, the first property that I have is the commutative property of addition and multiplication. And I kind of lump these together to hopefully save on the writing. Okay. The commutative property, what it does, it's changing the order of the add-ins or factors, but it does not change the sum or product. Okay. Notice I have underlined order. We're going to have another property coming up next, and the difference really is between the two is order, and the next one is grouping. So that's really a big deal. So if you can underline order there for me. And let's just look at an example. What does this look like? So for the commutative property of addition, if we have 3 plus 6, this is equal to 6 plus 3. And this is something you already know. We're just putting a property to it. For multiplication, 4 times 2 is equal to 2 times 4. Notice on both of those examples, the order of the numbers was switched around, but it didn't change the outcome. It still equaled the same number. The next property is the associative property of addition and multiplication. For this one, the associative property, we will be changing the grouping of the add-ins and factors, but it does not change the sum or product. So again, I've underlined grouping because there's a difference. Commutative changes the order, associative changes the grouping. So looking at an example of associative property of addition, if we have the quantity 1 plus 2 and plus 3, it is equal to 1 plus the quantity of 2 plus 3. Okay? So all we were doing was just rearranging those parentheses. Notice the order of the numbers didn't change. It was 1, 2, followed by 3. Each time it's just the parentheses that regrouped those numbers. Looking at a multiplication example, 5 times the quantity 6 times 7 is equal to the quantity 5 times 6, then times 7. Again, our order of our numbers stayed the same, 5, 6, 7, just rearranging those parentheses. The next set of properties that we have is the identity properties for addition and multiplication. Okay? Identity, think about it that it doesn't change the original number. So I like to explain it as each person has their own identity, and you don't want anyone else to change it. So these properties think, what can I do to addition to not change the original number? What can I do to multiplication to not change the original number? So the additive identity, that number is 0. And if we add 0 to any number, it's not going to change it. So 3 plus 0 is still going to remain at 3. The multiplicative identity is 1. Any number that we multiply by 1 isn't going to change. So 4 times 1 will equal 4. The next property is the zero property of multiplication. And what that is any number times 0 is 0. This is something we know. We're just putting a property to it. So 5 times 0, that always will be 0. And then the multiplication property of -1. I didn't put any words to this, but really if you multiply anything times a -1, it's going to change that sign. So 7 times -1 is -7. If we had, starting off with a -7 times -1, it would then change it over to a +7. So it's just going to change that sign of the original number. The next two properties aren't covered in section 4. They're covered in, I think, 5 and 6. But I thought this was a great place to talk about them. So we have all of our properties in one location. So the inverse property of addition. So this is where we need to keep things straight between identity and inverse. So the inverse, think opposite of the number. So if we start off with 14, the inverse property of addition would be adding that opposite. So 14 plus its opposite will always equal 0. Okay. The inverse property of multiplication, this is sometimes known as the multiplicative inverse or reciprocal. You guys have heard reciprocal before. So if we take the number 13, times it by its reciprocal, we're going to get 0. Okay, so notice, looking back at your notes, for your additive identity, the additive identity was 0. And then the inverse property, we're trying to get to that 0. Okay? Same thing with the multiplicative identity was 1. If we use the inverse property of multiplication, we're going to get to a product of 1. All right, so how are these properties helpful? We can use these properties for mental calculation, and I'm guessing most of you do this already. So I just have one quick example in here so you know how we can use this. So if we have the quantity of 7.75 plus 2.4, then plus 1.25, justifying our steps on how we solve this, we can first use the commutative property of addition. Rearrange what's inside those parentheses. So now I have 2.4 plus 7.75 inside the parentheses, and I still have 1.25 on the outside of the parentheses. Now why this was helpful, because on the next step, if I use the associative property of addition, notice I can rearrange those grouping signs. So by doing that, now I have 7.75 plus 1.25 inside my parentheses. For using mental math, we know that 7.75 plus 1.25 is going to equal 9. Notice we didn't have to line up any decimals when we were trying to add this. We could do this mentally. And if I was to justify these steps, all I was doing was simplifying. And finally, 2.4 plus 9 is 11.4. Okay? So that's one way to use those properties to just do your math maybe a little bit quicker. Alright, so let's look at writing equivalent expressions. And when we're writing equivalent expressions, most likely your directions are going to say simplify each expression, justify each step. Okay? In the previous example using mental calculations, I went ahead and justified each of my steps so that you've seen it a couple different times. So first example, 4 times the parenthesis 8n. Well, let's simplify this. The first property I can use is going to be the associative property of multiplication. I want to rearrange those grouping symbols so that I can do 4 times 8. Okay? Once I do that, I can do 4 times 8, which is 32, keep my n, and if I were to justify that, simply all I did was simplify. Okay? So got another example. 8xy over 2x. I want to simplify this and justify my steps. Well, the first thing I chose to do was write out 8 times x times y over 2 times x times 1. And this is the identity property of multiplication. I can take anything times 1, and I haven't changed that value. Now, I can separate out 8 over 2 times x over x times y over 1. And if I'm going to justify this, this is the rule for multiplying fractions. Okay, so I'm just expanding it back out. Now I can simplify. 8 over 2 is 4, x over x is 1, and y over 1 is y. And finally, I'm going to use that identity property of multiplication again, and I can simplify this down to 4y. I don't need the times 1 in there. Okay. Final item that we're going to talk about is deductive reasoning and counterexamples. And I just want to take a quick moment to talk about what each of those mean. So counterexamples, this is going to be an example showing a statement is false. Okay? And deductive reasoning, this is reasoning logically from given facts. So how can we use this? Let's look at, see, is this statement true or false? For all real numbers a and b, a minus b equals b minus a. Is this statement true or false? If it's false, can we give a counterexample? Well, I can think of one right away. So I'm going to say this is false. And the example I chose to use was 5 minus 3 does not equal 3 minus 5. Because if I simplify that down, 5 minus 3 is 2. 3 minus 5 is negative 2. Those don't equal each other. So if I'm looking back right here, the a minus b equals b minus a, that's a commutative property, rearranging that order. But again, we only have a commutative property for addition and multiplication. Order does matter for subtraction and division. Okay. That is all our notes for today.